Modeling with linear functions. When we use equations to model real-world phenomenon, we often look to linear models first, okay, because they're the easiest to understand. So we're going to use our skills from the last few lessons to be able to take these linear models and develop them and then answer questions about them. So some key pieces of information that we need to think about, always keep in our mind y equals mx plus b and our two parameters, okay, the slope and the y-intercept. Okay, that slope tells us how fast the output is changing relative to the input. The y-intercept, or b, tells us how much we start with, okay, our starting point, or the output's starting value when x is 0. So two key pieces of information to understand there. So our first exercise says Janine has $450 in her savings account in the beginning. She places money in the account at a rate of 5 per week. So right there we have our two parameters. We have our b, and this right here represents our slope, okay, or our average rate of change. It says we want to model the amount of money she has in her savings S as a function of the number of weeks she has been saving W. So S for savings, W for weeks. Fill out this table, show your calculations to get to your answer. So at week 0, okay, number of weeks, W, and the amount in her savings. So if we sit and think about that, at week 0, her starting point. So 5 times 0, okay, because she says they're adding $5 per week, plus she started with that $450. Okay, her starting point is $450. So at week 1, 5 times 1 plus our starting point gives us $455. Then they jump to week 5. So now she's added a total of $25 to her $450, and that gets her to $475. And then at week 10, she's added $50 to her already $450, and now she's at $500 at week 10. So use this given information or the table to write your equation for her savings S as a linear function of the weeks W. Well, in order to do our calculations, we know she's adding $5 per week plus what she started with. If Janine saves for exactly 1 year, what is the range of her savings over the year? So when she first starts out at week 0, we know she's got $450, excuse me, in her account. So now after 1 year, how many weeks is that? Okay, that's that background knowledge. There's 52 weeks in a year. So if we take our model, 5 times 52 weeks, because it's $5 per week, plus what she started with, that gets us to $710 at the end of the year. So her range goes from 450 all the way up to and including $710. Part D says, why would it not make sense to evaluate S of 6.5? Okay, so that W. Okay, does it make sense for the weeks to be 6.5? And in other words, what types of numbers belong in the domain? Well, the domain of this function is the number of weeks. And she's putting $5, okay, away per week. So what types of numbers belong in our domain? The types of numbers, okay, are whole numbers. They're whole numbers, 0 and on up. Okay, we don't have negative weeks, we don't have part of a week, so they're all our whole numbers. Letter E, what 2 points from the table, use 2 points from the table to verify that the rate of change, okay, for this function is 5. So you're proving that the rate of change is 5. How do the units show up in the calculation? So I picked, okay, these first 2 to work with. Doesn't matter which 2 you pick to work with. I picked 0 week and 1 week. So the points I'm using to calculate is going to be at 0 weeks she had $450. At 1 week she had $455. So my average rate of change is the change in the dollars over the change in the weeks. So I'm choosing to go 455 minus 450 divided by 1 minus 0, okay, dollars divided by weeks, which gives me $5 per week. All right, go ahead, flip the page. And exercise 2. So now this one says, sometimes the information we're given does not include our starting value. In other words, we don't have the y-intercept. Okay, but we learned that from last section that we still can write an equation even though we're not given the y-intercept. We're missing one of those parameters, as long as we know some other information. So it says Kirk is driving along a road at a constant speed. Okay, that's important to know because that's going to give us that tip that it's linear. He is driving directly towards Denver. He knows that after 2 hours of driving, he is 272 miles from Denver. Okay, he's driving there. Then after 3.5 hours, he's 176 miles from Denver. So he's getting closer to Denver. Summarize the information in the problem as 2 ordered pairs, meaning 2 points, where the number of hours h is the input and then the distance d is the output. So we're looking at hours comma distance. So at 2 hours he's 272 miles from Denver, and at 3.5 hours he's 176 miles from Denver. And then in part B they want us to calculate that average rate of change and to make sure that we put the units in. So our distance at 3.5 hours minus our distance at 2 hours. Okay, so they're telling us the order in which they want us to work in. So our distance at 3.5 hours was 176, minus our distance at 2 hours was 272. And they did the hours already for us. And we end up with, once we do that subtraction, we end up with negative 64 miles per hour. Well, that sounds kind of odd, negative 64 miles per hour. What does this mean in the context of this problem? Because clearly we didn't do any calculations that were incorrect. So it says down here, it says, you should have found that the rate of change was negative. Well, can we have a negative rate of change? Okay, we certainly can. That just indicates a negative slope. Okay, negative rate of change just indicates a negative slope. Why is it? Explain what is physically happening to result in this negative rate of change. So what's happening? Okay, remember what the distance is. His distance from Denver. So as time, okay, increases, his distance from Denver decreases. Okay, he's Kirk is getting closer to Denver. Okay, in other words, as time increases, his distance from Denver, that's the key word, from Denver decreases, indicating that negative rate of change. Right? Then part D says, assuming that the relationship is linear, which it would be because we said in the beginning it has that constant speed, constant rate of change, write an equation for the distance D as a linear function of the number of hours h. So D equals, we know that our average rate of change is negative 64 per hour. Okay, we don't know the starting point. We don't know how far he is from Denver. Okay, at the start, before he starts out. So we've got to do some work from here. So now, because we are only given, we only know one of our parameters. We only know our slope, or our average rate of change, but do we have a distance and a time to work with? to find this, do we know what a distance and an hour to work with in order to find our B? We certainly do. Okay, I'm going to pick the 176 and the 3.5 and the 176. I'm going to choose to use that. So my distance, okay, turn the green back on. So 176 equals negative 64 times 3.5 is going to give me his distance from Denver. So doing that calculation, I've got 176 equals negative 244 plus B, adding 224, sorry about that, 224, adding that 224 to both sides, I end up getting 400. Okay? So when he starts out, he's 400 miles from Denver. Okay? That B, that y-intercept. Okay? So it says, how far did Kirk start from Denver? Okay, we just found that right over there. So 400 miles. Okay. Show the work that leads to your answer. Okay, we definitely found B over there, but another way that we could show it, okay, is at time 0, D of 0, right? That's a starting point. So using our equation, negative 64 times 0, okay, hours, plus 400. Okay, we end up with that D of 0 is 400. Now it says, after how many hours will Kirk arrive in Denver? Show the work that leads to your answer. Okay. After how many hours? So we're looking for the H. Okay. So now when my distance is 0, because he's there, he's in Denver, because remember our equation shows the distance from Denver, so he's arrived. Negative 64, how long is it going to take us, H, okay, when we start 400 miles away? I'm going to add 64H to both sides. So 64H equals 400, divide by H, and I end up with 6.25 hours. Okay, so 6 hours and 15 minutes it's going to take him to get to Denver. Okay, not going to go through exercise 3, but the answer is 1. Go ahead and flip to lesson 7. We're going to do just a few questions from there. It's the same topic. So we're going to hop down to question 2. Okay. So now this one talks about money and running a factory that produces widgets. Okay. So the cost C in dollars of running a factory that produces W widgets can be modeled by this linear equation. So they're giving us the equation. How do you interpret the fact that C of 100 equals 2,300? What does that mean in the context of this problem? So what it means is, because notice what we underline here, C is the cost in dollars of running a particular factory that produces widgets. So if it's going to cost the factory $2,300 per day if it produces 100 widgets. Okay. Now it says give a physical interpretation for the two parameters in this equation, that 125 and then 2,175. So that 1.25 is the unit cost of a widget. Okay? Every one widget costs $1.25. And then that 2,175 is 2,175 is if no widgets are produced. Oops, no widgets are produced that day, okay? Something happened to the factory, maybe things shut down. Okay, if no widgets are produced, the cost to just run the factory is that $2,175. Okay, pretty expensive. Okay, $2,175 just to run the factory if no products are being produced that day. Okay, go ahead and flip it over and slide down to exercise 4. One last question. Okay, water is draining out of a bathtub. Okay, draining out of a bathtub. So think about what's going on there. Okay, that water level is going down, the volume still left. G gallons is shown as the number of minutes it has been draining. Okay. So we've got this in our table. Calculate the average rate of change of G over the interval. So they're giving us our time, and then make sure we include our proper units. So 0 minus 2 is my change in my time. Okay? So we've got a change in gallons over the change in time. Okay? So we're looking at those two values. So what goes with 0 is 62, and then what goes with 2 gallons, 2 minutes is 28 gallons. Doing that subtraction, we end up with negative 17 gallons per minute. Okay, again, the average rate of change is negative. Well, we can have a slope that's negative because what's happening in the context of this problem? The water is draining out of the tub, so the volume is decreasing as time increases. Now, part B says calculate the average rate of change of G over the interval 2 to 4. So now we're changing. We're looking from 2 to 4. So what goes with 2 is the 28 and the 12 with the 4. So that ends up giving us 16 over negative 2, which is negative 8 gallons per minute. Okay? Why can we say that the relationship between M and G is not linear? How do we know that it's not linear? If you look at those two rates of change, how do we know that that it's not linear? What do we know about the linear rate of change? Linear rate of change is always constant. Do we have a constant rate of change in this? Okay, it's not. This first one was negative 17 gallons per minute, and the second one was negative 8 gallons per minute. Okay, so our reason, like we say that the relationship between M and G is not linear, because the average rate of change is not, okay, constant.